The purpose of this lesson is to learn what a loop is and what its function is, how loops reduce repetitive code and functions, what a counter is and how to increment or decrement it, different types of loops and where they apply, how to nest loops, and how to use for each statements. The purpose of a loop is to reduce the amount of code that is necessary for repetitive functions. This allows the program to decide how many times something should happen. We also can use these for input validation. And what that means is we can make a loop where we ask the user to provide input to us, and if we expect that input to be in a certain format, let's say we expect it to be a number or a text field or something like that, and the user does not enter the correct type of data, then we can use a loop to decide if they entered something that's valid or not, and if not, then we can go back and ask them to enter that data again. There are different types of loops that can be implemented in most programming languages. These are going to be indefinite, definite, and infinite loops. An indefinite loop is used when it is not known how many times the loop will run. So let's say in the case of we're trying to validate data, we ask the user input a number, they input a text string. Okay, so we ask them again. So the loop ran once. And so when we ask them again, we say enter a number, they enter another text string. Oh, we're going to ask them again. We don't know how many times this is going to happen until they finally input something that's correct. The other time you'll see this kind of loop would be something like where the user is supposed to keep inputting data, and then every time they input data, then we ask the user to do something like enter a number and enter 999 if you want to exit. And so they enter the number 50. So then it goes back and it loops again. It says enter another number or enter 999 to exit. And we keep doing that over and over again. We have no clue how many times the user is going to enter a number before they finally exit out of the loop. This is typically going to be used to perform a function until something else occurs. These are great for use with event actions and input validation. So this works great for an object-oriented environment where we don't know which button the user is going to click on, how many times they're going to click on it, and so forth. A definite loop is going to be used when it is known how many times the loop will run. Now, we don't necessarily mean that I know that every single time the program runs, it's going to run exactly 10 times. What I mean is I may make a loop where we have to see how many rows are in our table. And then maybe we have to perform a function on every one of those rows. Well, I know how many rows there are, so I'm going to count them first, and then my program will go through and perform the loop that many times. We typically are going to use what's called a counter to keep track of how many times this one runs. We also have infinite loops, and these we don't want. What an infinite loop is when the program enters a loop, but there is no way for the user to get out of the loop. As far as the user is concerned, the program appears to not be responding and they think the program has crashed, but in reality, the program is sitting there behind the scenes just continually running this one loop. There are different ways that we can implement these loops in VBA. The most basic one is going to be a for next loop. This is a definite loop. This is one where we know exactly how many times it's going to run. So what we're going to do is we're going to use some sort of counter. We're going to say for each of the times that we want this thing to run, we're going to do something, and then we tell it to run it the next time, and then it goes back and it performs the loop again. We have do loops, which are infinite loops, and there are different types of do loops. A do loop just simply does something, it keeps doing it, and then we have to exit it somehow. So this is an indefinite loop. We don't necessarily know how many times it's going to run. It's going to perform a task until some condition is met. We also have a do while loop, which is another indefinite loop. This one will perform a task while some condition is true. So what we're going to do is we're going to say while the user doesn't click a button, or while the number is not equal to 100, count up from 1. That's going to be a do while loop. So we're going to keep doing it while some condition is true. We have a do until loop, which is another type of indefinite loop, and that's going to be one where we perform the task until a condition is met. So we're going to keep doing this. We're going to count from 1 up until we get to 100. So a do until would be do it until we get to 100. We have a while wend, and the when just simply means it's the while end. But the while when is another indefinite loop. We're going to perform a task while a condition is true. It's very similar to a do-while loop. The difference is where it evaluates it. In a do-while loop, the condition will be evaluated at the end of the loop. In a while loop, we evaluate first before we run it. So the question would be, what's really the difference? Well, the difference is in a do loop, it's going to perform the entire loop at least one time, no matter what, before it evaluates our condition to get out of the loop. A while loop, it will evaluate first, and there's a possibility that the loop will never actually run, because if we run the while loop and the condition is already true, then that loop never actually runs. So a do loop, if you want it to run at least one time, use a do loop. If you don't care if it runs or not, if we don't necessarily need it to run, then we're going to use a while loop. We also have a special loop type in VBA, and this is called a for each. And the for each is another indefinite loop, but what this one does is it looks at a collection and then it performs a task on each type of item that exists in that collection. So a collection is going to be something like an array or a table or a list or even a range. So what I can do is I can say, for each of the cells that exist in this range, do something. And so I don't have to tell it where to start. I don't have to tell it how many times for it to run. It just simply knows, hey, there are 20 rows, so therefore it's going to perform this task 20 times just because it knows how many rows there are. Whenever we play with loops, we typically need some sort of counter. And a counter is just simply a variable that is used to keep track of how many times a loop has occurred. It's just simply a variable. We usually use the variable I or the variable k. I means iteration and k is the hard C sound, so counter, so k is used. We also have this thing called a step value, and a counter is usually incremented. So the counter has to be added to or subtracted from. So what I mean by that is if I start my counter at 1 and I increment it by 1, that means I add 1 to it every time the loop runs. So the first time the loop goes through, k is equal to 1. The next time the loop goes, k is equal to 2. The next time, k is equal to 3, and so forth. If we decrement, that means we're counting down. So if I'm decrementing by 1, I would start at 10, and the next time I go through the loop, then k is equal to 9. The next time I go through the loop, k is equal to 8, and so forth. The step value can be changed. If I don't specify 1, it will automatically note the step value is 1. However, I can change it so I can have other numbers. And what we do is we use this to count by. So if I want to count by 2 or count by 3 or some other value, then we're going to use a different stepping value. All right, so in this loop here, we have a for loop. K is started off at 2. We want to count up to 10, and our step value is 2. So what will happen is the first time that our loop runs, k is equal to 2. We do something, and then when we come down here, we say next k, it increments k by 2. So now k is 4. Okay, it's still less than 10. So we do something, we increment it again by 2, so now it's 6. Do something, next k, now it's 8. Do something, increment it by 2, now it's 10. And then now we're equal to 10, so we'll actually get out of the loop. Now one catch is that our k here, it actually will get incremented one last time down here. So be aware of that. When you come down here, k is actually going to exit and be equal to 12. Sometimes you'll have a loop that is going to run for a long time, and we don't necessarily want that. So if I'm trying to evaluate if something is true, or if I'm looking for a specific row or something like that, and what I'm looking for is at the top of the list, I don't necessarily want the system to keep going through and checking every single row underneath it to see if it's the one I'm looking for. So we have this process where we can do what's called short circuit the loop. And what we're going to do is we're going to get out of the loop by using an exit for command. What this does is it's used to prevent the loop from continuing after some sort of condition is met. We're going to use this for attempting to validate data. The catch is that we have to use an if-then statement, which will be covered in the next lesson. So I will cover the exit for very briefly here, but the if-then statements will be covered more in depth later. Sometimes it is necessary to put a loop inside of another loop. This is called a nested loop. The catch is that we need to make sure that the opening and closing tags correspond to each other. So what that means is that the for loop on the outside is going to correspond with the next command on the outside. And then the for command on the inside would correspond with the next command on the inside. If you do use nested loops, actually with any loops, make sure that you indent. It makes it so much easier to try to follow it. Now these lines here, I put these lines in, they don't actually exist when you make your code, but it's just for you to be able to see that this for command goes with this next command, this for command goes with this next command. But if you do your indenting, what will happen is this loop runs, then it kicks this off. All right, so the way that this works is we will say for k is equal to 1 to 10, and I didn't specify a step, which means it's going to increment by 1. Then what happens is the first time we go through, k is equal to 1, and then it gets into here and it says for I equal to 1 to 3, and the step is 1 because I didn't specify one. Okay, so what will happen is this one on the outside ran only one time so far. This one on the inside runs, but it'll do something and it says next I. So it goes back up to here, increments I by 1, so now I is 2, k is still 1. We're still getting up to 3, so we do something, we increment I by 1, so now I is 3. We do something, we increment I again, so now I is 4, and then we get out of the loop. All right, so now we get out of this loop here, but then we go back to this line. This next one says next k. So then what it does is increments k to 2. It starts this loop over again, so it starts I back at 1, and then it does this thing 3 times, and then it does the next k. And it'll do this one, now k is 3. Then it comes down here and does this 3 more times. Then it does this one, and k is 4. And it'll keep doing that. So this inner loop in here, the whole loop will actually run 10 times, and it counts from 1 to 3. So this loop is actually running 3 times. Each time this loop out here runs once. So when it all is said and done, whatever this do something is will actually have occurred 30 times. I open up a new workbook and I want to show you how some of these loops work. So I'm going to bring up the VBE by doing my F11, and I'm going to make a new module. So insert module. And what I want to do is I want to start playing with loops. So I'm going to make a new sub for loops. Call it looping just to make sure loops isn't a keyword. All right, and what I want to do is I want to make a loop that uses a counter and will start putting values into the cells. All right, so we talked about the cells, and the cells are going to be in row, comma, column. It's always going to be row and column. And so what I'm going to do is I want to make a loop that just simply starts counting down through these cells, maybe 1 through 20. All right, so what I'm going to do is I'm going to make a for loop. I'm going to say for I equals to 1, 2, and then how high do I want it to go? I want it to go to 20. All right, what do I want it to do? All right, so I'm going to indent, and then I'm going to say cells, and I want the first column, but I want the row to change. Now what happens is the row here is going to be row 1 the first time I put it in this first cell. It'll be row 2 the second time, row 3 the third time, and so forth, which means I can use this counter for that value. All right, so I'm going to put I, then comma, and then I want column 1, because this is the column for A, dot value, and we're going to set this equal to whatever I is. And then when we're done, we just simply say next I. So what it will do is it'll start at 1, it'll say I is 1, and so in cell 1, 1, which is A1, it'll put the value equal to I, which is 1. Next I, which means it increments I by 1, so now I is 2. And then what it does is it says in column 1, which is A, cell 2, so A2, set the value equal to 2. Next I. Now I is 3, so now column 1, row 3, set the value to 3, and so forth. So when I run this, it goes through, and in a loop, it puts them in. Now the catch is that you don't actually get to see it run. So what I'm going to do is I'm going to delete these values. And delete them. Bring it. right? And so what I want to do is I want to step into this. All right, so I'm going to come up here, and if you notice on the debug, step into is F8. So I'm going to step into, and then what I can do now is I can keep stepping into it. And you watch, the yellow is the one that's going to run next. All right, so cells, and it's going to be row 1, column 1, set the value equal to 1. Go back through, and so now what it did is it just took I, and if you notice if I hover it, I is equal to 2. It will actually show me what the value of I is when I hover over top of it. All right, so if I do F8, now it does 2. Now I is going to be equal to 3. Now to do the third row, now I is equal to 4, and so forth, and they'll keep doing this. So what it's doing is it's going to keep doing this until it gets up to 20, and then it stops. So as you go through, you can watch it add all of these values into each of these cells, all the way up through 20. Now that we're up to 20, it's done. And it actually exits the loop, and it exits the sub. I want to play with a nested loop. So what I'm going to do is I'm actually going to add another loop here inside of this loop. So I'm going to say for, and this time I'm going to call it K, and this is going to be equal to 1, 2, and then let's say up to 5. And we're going to do next K. Now I told you that whenever we do our loops, we want to make sure that we nest them properly, which means that this for loop here goes with the outer next here. The for keyword goes with the inner next here, and these belong together. Notice the indenting makes it real easy for me to figure out where things belong. All right, what I want to do is I want to start saying that my cells are going to be a multiplication table. All right, so what I have is I have 20 rows, and I want to go 5 columns across. So we're going to go to E, and I want to fill in a multiplication table. All right, so the way that I'm going to do this is I'm going to say cells, and then cells, remember, is row index. Okay, so what's keeping track of our row? Well, I is keeping track of our row. K is going to keep track of our column. So what I'm going to do is I, comma, K, and then the next thing I can do is I can do dot value, and that's going to be equal to whatever I times K is. So I can do something like this. And so what we'll do is we'll specify that the row I, column K, is going to be equal to those two multiplied together. So now if I run this, I end up with something like this. It looks like a multiplication table. So this is a nested loop. We just simply put 2 loops inside of each other, and then we just have to make sure that we properly nest them, and the indenting really helps to try to figure this out. All right, so the question is, how did this actually work? And like before, we actually couldn't watch it run. So what I want to do is I'm going to delete these. It'll let me delete them. All right, and what I want to do is I want to step into this. So I'm going to come up here to debug, step into, which once again is F8. So I'm going to keep using F8. All right, so now I is equal to 1 and K is equal to 1. That's how it starts. So cell 1, 1, so column 1, row 1 is going to be equal to 1 times 1. And so if I keep stepping into this, you'll see that we now get a 1 there. Does the next K. And you'll notice it goes back up inside of this loop because it has to finish this 5 times before it can go back to this outer loop again. All right, so now we're up to row 1, column 2 is going to be 1 times 2. So now we get our 2. Goes back up again. So now we have 1, 3 is going to be 1 times 3. And so we run again, and we'll keep doing this as we go across. And so now it finishes out the row, and now it goes on to the next I, so it goes back into the next column. So now what we're going to do is we're going to say that I is now equal to 2, K is equal to 6 right now, but what happens is K is going to get reset back to 1 after this runs. Okay, so I'm going to step into it, and what you'll notice is K went back to 1 now because we reinitialized it. All right, so now it'll go across that second row. It runs this inner loop 5 times, then it goes back to the outer loop, and it goes to the next row, runs it 5 times, and so forth. All right, so what this is going to do is it's just going to build our table for us by just simply having two nested loops. And if I want to watch it finish, then I can continue, and it runs all the way through. The next question would be, what would happen if I were to use a different stepping value? So I'm going to delete these again. Bring up the VBE. And instead of going from 1 to 20, I still want to go 1 to 20, but I'm going to step by 2. All right, so what this will do when I step into this, I'm just going to make me go to debug, step into. All right, so then I can do F8. I is equal to 1. We're going to go all the way up to 20. So this will function like it did last time, where it does this first row. Okay, so now the thing is that what happened was when it stepped by 2, I is now equal to 3, which means it's going to skip a row. All right, so now when it places the values, it completely skipped row 2. Go on to the next row, and now we skipped a row, and now we ended up with 5. So it's only doing the odd number rows. All right, and what I did is I simply controlled that by changing my step value for the outer loop. All right, so I'm going to go ahead and stop this, and I'm going to delete my values over here again. And what if I wanted it to do every other column and every other row? Okay, so then what I would have to do down here would be for my my for loop that controls the column, then let's put this up to 6 so we have an even number, and let's make this step by 2. All right, and then if I run this, now I end up with something where it skips every other column and it skips every other row. So what that allows me to do is control which cells are going to actually have values based on the value for the counter for the particular loop. Now I'm going to put this back to our original table. And so we're going to get rid of these stepping values. And I'm going to let it run the table. And so it generates this thing. And what I want to do is I want to tell it that if the number that we have is, let's say, bigger than 40, because we want 39 to be our last one, we don't want this 52. What we want to do is we want to tell the loop to stop running. And the way that we're going to do that is by using an if statement. Now we're going to cover those a lot more in the next lesson. So if you don't understand the structure, it's okay. But I just want to show you the basics on how this works with the loop. So what I'm going to do is I'm going to put a statement in here that says if I times k is greater than 40, then I don't want it to do anything else. Now what you'll notice is that I end up with 40 here. I end up with 40 here. I end up with a value that's bigger than 44 here, and so forth. What I'm going to do is I'm going to cause the loop to stop the first time that it finds something that's equal to 40. All right, so I'm going to say if I times k is greater than 40, then we're going to do something. All right, the question is, what are we going to do? So we're going to put an end if here, and we're going to actually use a command that will allow us to get right out of the loop. So what I'm going to do is I'm going to tell the system that if this is true, then we want to exit the for loop. All right, so what this will do is if this becomes true, it flat out exits the loop. All right, so I'm going to go ahead and clear these again. All right, and I want to run this, but I'm going to go ahead and debug it so I can step through it. Okay, so we're going to step into it here. We're going to get into the loop. We'll start writing values. Now it'll take a little while to get up to our 40, but what I'm doing is I'm going through the loop, and when we saw the 40 would be in just a couple of rows here, so we're up to 25. Okay, so 30 in this row, 7. Okay, so here comes our 40 in the next row. Now the catch is, the reason that it stopped is I times k is going to be 7 times 5 is 35 here. Well, in the next one, we would have 8 as our outer loop value, and then we'd have 5 still as our inner loop value. So what it did is it actually flat out exited the loop before it even had the chance of getting that 40. And depending on where we put this x at 4, that will determine when it exits our loop. But it's just simply a way for us to short circuit the loop and get out, so that way it doesn't do the rest of the stuff that's in the loop. You're not going to use this very often, but it is there and available if you need it. The next type of loop that I want to play with is going to be a while loop. And so what we're going to do is we're going to make our loop, and we're going to simply allow the system to keep putting the values down the first column like we did originally. All right, so I'm going to go ahead and get rid of these values here. I'm going to go back over to VBE. Why is it let me click on it? All right, and what we're going to do is we're going to make a while loop. So what I want to do is I want to tell the system that while the value that goes in the cell, or actually let's keep track of a counter. So while our counter is less than 20, then we're going to keep incrementing our cell here. All right, so what we're going to do is we're going to put this back the way that it was before. We still need to use this. We're going to use this one like we did before. Now K was going to be our column 1. So what we're going to do is we want to put the value of whatever we're using as I. All right, so what I want to do is I want to tell it that I want to reproduce the for loop that does the values of A1 through A20 as the actual value for whatever the counter is. One of the catches to a while loop is that we don't initialize a counter as part of the actual while statement. So unlike a for loop where we say for I is equal to and we start off I at something, in a while loop we actually have to create the variable first to be our counter. So I'm going to say dim because I want to dimension a variable called I, and I'm going to start it as an integer. And then what I want to do is I want to give I an initial value. So I'm going to say I is equal to 1. All right, so that's outside of the loop. All right, so then what I need to do is I need to figure out what my actual condition is to get out of the loop. So we're going to use what's called a do while loop. So we're going to do while something is true. All right, so while I is less than 20, I want it to perform this calculation, or sorry, do this particular thing and put these values in these cells. Then what we're going to do is we're going to loop back around. And so what happens is we start off with I is equal to 1. So I is 1, which is less than 20. So this is true. It'll run this. And then it loops back around. All right. Now I is still equal to 1. It does this again. It loops back around. I is still equal to 1 and so forth. So what I actually just created is what's called an infinite loop. So I have a loop that there's no possible way to get out of. Now the problem is that I need to actually increment my counter. So in a for loop, the step value automatically does that. When we have our next value, that is what's incrementing our counter. Well, in this case, I actually have to increment our counter. So I'm going to say I is equal to I plus 1. And what that'll do is it'll perform this task. Then it increases whatever the value of I is by 1 and puts that back into I. So if I is 1 to begin with, then we're going to say 1 plus 1 is 2. Put that back in I. So now I is 2. We loop. And now we have I is 2, which is less than 20. It does this. It increments I becomes 3. Loop back around. 3 is less than 20 and so forth. So what we're doing is we're allowing the system to increment the counter, but we had to manually create it because a while loop does not have a self-declared and incremented counter. All right, so I'm going to go ahead and debug this. I'm going to step into it, and then I'm going to use my F8 keyboard shortcut. Okay, so I start off with created an integer called I, set I equal to 1. Now notice I is equal to 0 right now because this is the step that's going to run next. And then if I come down here, now I is equal to 1, which is less than 20. So it's going to look at cells row 1, column 1, and it's going to set that value equal to 1. And then it takes whatever is currently in I, adds 1 to it. So 1 plus 1 will be 2. And so now I is equal to 2, and it will loop back around. Okay, so now what it does is it evaluates, is 2 less than 20? Yes, it is. So now it's going to go back into here, and it'll do this again. And it keeps going around up until we get to 20. So just like we did before, we're going to go through our loop all the way up through 20. And I'm just simply stepping into it. Okay, so now we're up to 19. All right, so we're going to loop around again. And so now what we're up to is that I is 20. Okay, so is 20 less than 20? No, it's not. So it actually will get out of the loop. So the catch is that I just created a loop that it will not get up to 20 like I want it to. All right, so there are a couple of ways to fix that. The easiest way to do it is to make this less than or equal to. So what we can do is we can evaluate all the way up through there, and then we'll do all of our 20 if we run it. Another way to do it would be to change where we increment our counter. So what I'm going to do is I'm going to start off our counter at 0, actually. And then I'm going to take this section of code here, cut it, and then I'm going to paste it right above where I actually change the value for ourselves. Okay, so what I did was just change the logic just a little bit. We start off, the first time we run the loop, I is equal to 0. So 0 is less than 20. And then we increment 0 by 1 and set it equal to 1. And then we run through our loops. All right, so what will happen is when we get up to the 19th time that it ran it, the 19th time that it runs it, it's going to be equal to 19. 19 will still be less than 20. It takes 19 plus 1, makes it 20, and then it will do our 20th row. So if I run this one, this will do all 20 rows. All right, so let's go ahead and delete this. All right, there are a couple of other ways we could do it. We could say, do this while I is not equal to 20. All right, so now what we're doing is we're going to use a keyword called not, and that will allow us to evaluate the opposite. So in this case, I'm evaluating is I less than 20. Well, what if I don't want it to equal to 20? I want it as soon as we get up to 20, then we're going to get out of it. All right, so if I were to just simply change this to do while I is equal to 20, this wouldn't run at all. But if I add the keyword not, now we're telling it while it's not equal to 20, do it. Okay, so I is 0. 0 is not equal to 20, so this will run. All right, so let's go ahead and debug it. Step into it. Do our keyword shortcut. Okay, so while I is not equal to 20, I is equal to 0, not equal to 20, so this is true, and it will actually run the loop. And it'll keep going through the loop all the way up until we get to 20. All right, so what happens here is when we run this, it still runs all the way through it, because when it did the last one, it got up to I is equal to 19. 19 is not equal to 20. We took 19 plus 1, which is 20. We did our 20th row. And then now we go back around and 20 is equal to 20, which is true, but we want the not, so then it gets out of the loop. Nots seem to get a little confusing, so instead of doing a while not, they actually have what's called a do until. All right, so we're going to do this until I is equal to 20. It's a lot easier for us as humans to understand the positives instead of the opposites and the nots and so forth. So what we're going to do is we're going to keep doing this until I is equal to 20. So we're going to start over. All right, so we're going to do this until I is equal to 20. We'll debug it, step into it. And so we go through I is equal to 0. I is 0, which is not equal to 20, so we're going to do this because we're going to keep doing it until that condition is true. All right, so we go through our loop and we end up with the same thing. So now if I were to run this all the way through, we end up with the same type of result at the end. So we end up with all the way from 1 through 20, and we just have different types of loops that we can use. So I used a for next loop, I used a do while loop, I used a do while not loop, and then I also used a do until loop, and all of those perform the exact same task. The only difference is going to be what is my condition here and where do I increment the counter. That would be the only thing that would make it different. So whenever you want to run one of these loops, make sure you run it and make sure your output looks the way that you expect it to look. What I mean by that is the first time that I ran this thing, I only went through from 1 through 19. That's not what I wanted. I wanted to go from 1 to 20. So if you run it and you don't get the expected results, that means that either your conditional statement up here, how you actually get out of the loop, or where your counter is, or how you initialize the counter is wrong. But one of those three is typically going to be incorrect if you don't get the right results. All right, we also have a while when loop. I'm going to delete these, go back, and instead of a do until, I'm going to say while. And then what I'm going to do is a when here. Okay, now this works a little bit differently. This doesn't actually have a loop condition. This has a condition to exit. All right, so what I want to do is while I is less than 20, then we're going to do this stuff. And then when this is actually true, then we end the while with a when statement here. So what I'm going to do is I'm going to run this, and this will function similar to the do while loop. Now the difference between a do while and a while is where the conditional is actually evaluated. The while loop will evaluate is I less than 20 before it runs it. The do loop will evaluate it after it runs through the entire loop contents. So just be aware that there is a difference on where that runs. So if I step into this, okay, we start off with 0 is less than 20. So while 0 is less than 20, perform our loop, and then it goes back through and we have the same thing that we had before. All right, so that's just another way that we could actually do this. The last way that we could do this is going to be a for each loop. And the way that we're going to do this one is I'm going to give it a range. And then within that range, I'm going to tell it to actually perform our loop. Now for this one, I'm going to leave our values over here the way that they are. And because we don't actually need them, we need the numbers. We're not going to actually be putting the values in there. So what I'm going to do is I'm going to create a whole new sub routine here. And I'm going to say sub, and we'll call it for each. And then you'll notice it created a line here, and this line just simply is a divider between the two subroutines. All right, so what I want to do is I want to tell the system that for each one of the cells that are over there, I want it to color and bold all of the even numbers. Now the way that we're going to do this is we're going to use two things. We're going to use a for each loop, and then we're also going to use an if-then statement. Like I said, we'll cover those a lot more in the next lesson. But what I want to do is I want to look at for each cell, and cell, by the way, is a keyword, or could be a variable too, in the range of A1 through A20. Let's see, forgot. Set of double quotes here. All right, so for each cell in the range, what I want to do is I want to tell it that it's going to perform something. So what we have to do then is we have to tell it, well, the next cell is going to run. So for each cell that's in the range, we do something, then we go back to the next cell. And keep doing this all the way through the end of the range. We don't have to tell it each individual cell to work on. It just automatically knows that there is a range here, so it's going to work on each one of the things that's inside of there. All right, so I'm going to make a selection statement here. And so what we're going to say is if the cell dot value, and the way that you know that if something is divisible by 2, there's this thing called a modulus, which is your remainder. If you think back to elementary school, when you took a number and divided it by another number, before we knew about fractions, we used the r and then put some number after it when we divided them. So like if I took the number 2 divided by 2, then what I would get would be 1 with a remainder of 0, so there'd be no remainder. So the remainder is what's called modulus. And so what I can do is I'm going to take whatever the value is and then do what's called a mod 2. So what we're doing is we're going to divide it by 2 and see what the remainder is. And if that's equal to 0, then it must be an even number. So if that's the case, then we're going to do some things. Well, what are we going to do? Well, I want to take the cell and we're going to make the font bold. So we're going to set that equal to true. And then we're also going to set the cell font color equal to an RGB value. Now RGB is our red, green, blue, and if I open this up, it'll tell you that it's red as an integer, and the values are going to be 0 through 255. This is the same thing that you use if you do web design. Remember, your colors on your screen are red, green, and blue, and all three of those on make everything white. So what I'm going to do is I'm going to tell it that I want all the red pixels turned on, none of the green ones, and none of the blue ones. So what I'm doing is I'm telling it that for each of the cells that's in there, if the cell's value, modulus 2, is equal to 0, so if that value is even, then we're going to make it bold and we're going to make it red. And then it'll end if, and then it'll go back around. Now, when I'm up here, if I click run up here, run will actually run this whole section of code. If I'm down here and I click run, run will run this section of code. It only runs the one where you actually selected it. So what I'm going to do is I'm going to debug this, and I'm going to step into, and you'll notice that we actually start at the for each. All right, so if I step into it, we start off with for each cell, and the cell is empty right now, but if I go next, now cell is equal to 1. It knows the first cell in this range. So the cell 1, if the cell 1 dot value, which is 1 right now, modulus 2 is equal to 0, so then we're going to make it bold and red. Well, that didn't happen, so skip right over, and now what we're going to do is we're going to tell it to do the next cell. And so if I step back into it, we go back up, and now what it's doing is it's looking at the second cell in the range, and the second cell is 2. 2 divided by 2 is 1 modulus 0, which means the remainder is 0, so therefore it's an even number, and it'll be true, so therefore we've set it to bold, and then we also change the color to red. And if, and then we now go back to the next cell. So the next cell is 3. 3 is not even, its modulus would not be equal to 0, so therefore we skip over, go on to the fourth cell. 4 divided by 2 is 2 with no remainder, so therefore it's even. So we make it bold, we make it red, and then we go on to the fifth cell, and so forth. So we go through all of our cells, and what we're doing is just simply looking to see if they're even. And if they're even, we make them bold and change the color to red. Go all the way through all of our cells in this range, and when we get down to our last cell here, so we are on 20, so now 20 is red. Now we've gone through all the cells in the range, and it exits that for each loop. So now it actually ends this up. So what it did is it went through all of those values without me having to have a counter, without me having to tell it exactly which cell it is. And the reason this is useful for us is sometimes we'll have a range that we don't know how many things are in it. So in this case, I know that it was A1 through A20, but that may not always be the case. And if I have a range and I don't necessarily know what all cells are in it, I can just simply say for each of all the cells that are in this particular range. And even if we add 20 new cells to a range, it will just automatically go through all of those cells for the loop. In this lesson, you learned what a loop is, and you learned what its function is. You learned how loops reduce repetitive code and functions. You learned what a counter is, and how to increment or decrement it. Remember, increment means to increase, decrement means to decrease, so we add or subtract. You learned about the different types of loops and where they apply. We have indefinite loops where we don't know how many times it'll run. We have definite loops where we know how many times it'll run, and then we have infinite loops where we never get out of them. We have our do loops, we have do while loops, we have do unto, we have our for next, and then we also have our for each. You also learned about how to nest loops. Make sure when you nest your loops that you indent so that you can properly tell where the beginning and closing for each of the loops is.